Hello everyone, my name is Ryan. Today we're reading Metamorphic Rocks in the Rock Cycle. Contents. 1. Metamorphic Rock. What is metamorphic rock? Metamorphic rocks in a wet rock cycle. How metamorphic rocks are formed. So we're going to read the whole entire story. Content scale. Properties of rocks. Metamorphic rocks. Supertite is a metamorphic rock that can be scratched easily with a knife. Found along with the Illinois River in Oregon, this schist rock is lined of quartz. The word metamorphic refers to something that changes. Metamorphic rocks got their name because they form when one kind of rock changes into a different kind of rock. Right. This is a close-up view of a cliff made out of granite garnet rock. Metamorphic rocks. What is a metamorphic rock? Earth is made up of three kinds of rock called igneous, sedimentary, and metamorphic. Like our planet, these rocks are always changing. Igneous and sedimentary rocks can change because of strong heat or pressure. A new kind of rock is formed from this change. New rock that is formed from heat and pressure is called a metamorphic rock. Metamorphic rocks have been Earth for millions of years. They can be different shapes, size, and colors. Metamorphic rocks are used to make buildings, jewelry, powders, and other things. They are an important part of the world. Metamorphic rocks have been on Earth for millions of years. They could be different shapes, sizes, and colors. Content scale. The rock cycle. Metamorphic rocks in the rock cycle. The rocks that make up our planet are constantly changing through a process called the rock cycle. In this process, old rocks are broken down to form new ones. Though the rock cycle is the several layers that make up the Earth, rock cycle is the several layers that make up the Earth are always changing too. Earth's top layer is called the crust. It's made of rock. Below the crust is a layer of hot liquid called magma. Earth's core is the next layer. The core has two layers. The outer layer is The outer layer is made of melted metals. The inner layer is a solid ball of metal. The rock cycle starts with a hot magma flows through cracks in Earth's surface crust. Once on the surface, the magma cools and hardens into igneous rocks. When these igneous rocks wear down, they settle to the bottoms of the rivers or oceans. Over time, they form layers of sediment. Pressure changes these layers to sedimentary rocks. Strong heat and pressure can cause these rocks to change from an igneous or sedimentary rock into a metamorphic rock. Metamorphic rocks then break down over time and form new layers of sediment. This forms sedimentary rocks. The rock cycle continues. This diagram shows the changing of old rocks into new ones through the rock cycle. Metamorphic rocks form through strong heat and pressure. The rocks that make up our planet are constantly changing through a process called a rock cycle. Content scale. Methods of formation. Pressure. This shows the metamorphic rock quartzite is in Israel. What do the Rocky Mountains, the Alps, and the Himalayas have in common? They are made mostly of metamorphic rocks. Right. The metamorphic rock quartzite is the only major rocks that make up Rocky Mountains in Colorado. How metamorphic rocks are formed. Under pressure, metamorphic rocks can form into two different ways. One way is through major pressure inside Earth. Earth's layers are heavy, and they can press down on each other. This causes pressure to build up. The pressure pushes or forces rocks into one another. The rocks are put under so much pressure that it causes their minerals to change. This creates metamorphic rocks. When the strong pressure continues, sometimes the metamorphic rocks are pushed up and out of the crust. This creates mountains. Most of the Earth's mountains are made of metamorphic rocks. Earth's layers are heavy. They press down on each other. This causes pressure to build up. Methods of formation. Heat. The heat is on. Forces inside Earth do not just create pressure, they also create heat. When Earth's layers are pressing down on each other and creating pressure, they force hot magma up toward the surface. Sometimes this magma escapes through volcanoes when they erupt. Other times, just a small amount of magma is able to push through a crack in Earth's crust. This is called a magma surge. A volcanic eruption or magma surge creates a large amount of heat in Earth's surface, making the rocks around the magma very hot. The rocks can become so hot that the minerals inside a rock change. The minerals that can change so much that they form a new kind of rock, a metamorphic rock. Metamorphic rocks form when the temperature around rocks get as hot as 300 to 2,000 degrees Fahrenheit, or 149 to 1,093 degrees Celsius. Metamorphic rocks form when the temperature around rocks get as hot as 300 to 2,000 degrees Fahrenheit, 150 to 1,000 degrees Celsius. Content scale. Methods of formation. Movement of Earth's plates. Plates on the move. Earth's crust is not one solid piece. It is made of large pieces called plates. These plates move around the top of the layer of liquid magma. This means the Earth's surface is always moving. Even though we cannot feel Earth's surface move, metamorphic rocks are a proof of Earth's movement. Sometimes the plates bump into each other and they can push the land up to create mountains. The pressure that forces these rocks out also changes their minerals. This is why mountains are mostly made up of metamorphic rocks. Sometimes plates scrape against each other. This forms a weak spot in the crust called a fault line. When the pressure inside Earth gets too strong, the plates shift so much that an earthquake occurs along the fault line. Volcanoes also form along fault lines. Hot magma can burst through these cracks and reach the surface. The tremendous heat and pressure of volcanoes and earthquakes change the molecules in the rocks, creating metamorphic rocks. Sometimes plates scrape against each other. This forms a weak spot in the crust called the fault line. Content scale. Properties of rocks. Slate is a type of faulted rock. You can tell it is faulted by the cracks. Marble is a non-faulted metamorphic rock. It is used for building. Scientists study what metamorphic rocks are made by breaking them into small pieces. They can cut a thin piece of the rock and look it under a microscope. This allows the scientists to see the minerals inside a rock. Scientists also break a rock into powder to study the minerals inside. Right. These red granite rocks can be found along in the water in Brittany, France. Faulted and non-faulted. Sometimes pressure forces the minerals in metamorphic rocks into wavy lines. This created into a faulted rock. Slate is a kind of faulted rock. Other metamorphic rocks are non-faulted. These rocks are smooth and often form heat or low pressure over a long period of time. Hornfels are an example of a non-faulted rock. Scientists can tell what a metamorphic rock used to be studying the minerals inside it. The non-faulted metamorphic rock marble is found from limestone, a sedimentary rock. Scientists are able to see the mineral calcites in marble. Identifying rocks. Faulted. Gneiss, slate, and schist. Gneiss is one of the most well-known metamorphic rocks. It is formed when heat or pressure changes an igneous rock called granite. Gneiss is faulted and has many stripes in it. These stripes are formed because the minerals in the rock separate into layers as the metamorphic rock is formed. A sedimentary rock called shale can change into a metamorphic rock called slate. Slate is Shale is found from sediment in rivers and lakes, which has been. Slate is used to make tiles on the roofs, houses, or to create sidewalks. Schist contains a mineral called mica, which makes it flaky and hard to use. Which has been pressed together over time to form a rock. Shale becomes slate through low heat or pressure. Slate is hard and breaks easily into flat pieces. It is usually gray, but it can also be red, black, green, or purple. Slate also changes into a different kind of metamorphic rock called schist. Schist forms when slate reaches a high temperature. Scientists are valuable because the minerals in them often form a gem called garnet. Garnets are usually red, but they can be also yellow, light green, or even colorless. Identifying rocks. Non-faulted. Marble, quartzite, and hornfels. One well-known metamorphic rock is marble, formed in the sedimentary rock limestone. Marble is made mostly of the one mineral calcite. Pure marble is soft and can be scratched with a knife. It is often white, but it can be yellowish brown, black, red, or green. Different colors are the result of faults in the limestone from which the marble formed. Marble is the most widely used metamorphic rock because it is easily carved into statues. Its stones used for building. Quartzite is an important metamorphic rock. It is a very hard rock that can scratch glass, and it's sometimes used to build roads. It forms when the sandstone, a sedimentary rock, is changed by heat and pressure inside Earth. Quartzite is one of the major rocks that form in the Rocky Mountains. Another type of metamorphic rock is hornfels. This rock forms when a sedimentary rock called shale comes in contact with hot magma at temperatures from 392 to 1,472 degrees Fahrenheit. 200 to 800 degrees Celsius. Hornfels is a hard rock that comes in dark colors, either gray or black. It is used to create roads. Content skill, minerals. Selenite, a metamorphic rock mineral, it is used to make car parts. Andesite is a metamorphic rock mineral. It is used as a gemstone. Quartz is a hard mineral that is often used to make jewelry. It is found in the metamorphic rocks, in the igneous and sedimentary rocks too. Right, kyanite, another metamorphic rock, forms in low temperatures. Minerals and metamorphic rocks. Metamorphic rocks often contain minerals not found in other rocks. Because the minerals are changed by the strong heat and pressure that is created by the rocks. The changed minerals include kyanite, selenite, and andesite. These minerals can withstand very high temperatures and are strong. They are often used to make insulation for heating and electrical machinery. The minerals in a metamorphic rock help scientists identify the rock. A metamorphic rock called chromite contains a mineral called chromium, which is the element symbol Cr. A metamorphic rock called chromite contains a mineral called chromium. The importance of metamorphic rocks. Metamorphic rocks are very useful. People use them to make different things. Buildings, roads, jewelry, and insulation are a few of the things made from metamorphic rocks and their minerals. Metamorphic rocks are also an important part of Earth. These rocks help scientists learn about appearance, location, and their minerals provide clues and facts about changes in above and below Earth's surface. The rock cycle has been changing Earth for millions of years. Metamorphic rocks are an important part that change. They're part of the process that creates new rocks. The rock cycle will continue as long as Earth does. Metamorphic rocks will help you go to that cycle go on. Rocks names. So here are rocks names. Serpentine. One metamorphic rock. Quartzite. Red granite, slate, and marble. Genus, slate, and schist. Marble, quartzite, and hornfels. Selenite and andesite. Kyanite and andesite. Glossary, core, crust, fault line, foliated, igneous, insulation, jewelry, magma, metamorphic, minerals, molecules, non-foliated, plates, sediment, sedimentary, temperature. The end. Make sure you like and subscribe. This next book is a similar one, but it's a bit more bigger than this one. So, bye-bye!